Today I will be rewiring the featherweight that you see back here. This is a painted featherweight. My friend Marie has painted it for a customer and I think it looks beautiful. But I'm just going to show you a few tips and tricks that I have learned when it comes to rewiring these machines. I want you to know this is how I do it. These are things to just take into consideration. What you choose to do is entirely up to you. And if you're not comfortable with any of this, you should definitely find a professional to help you with this part. But let's jump in, and I'm going to first tackle a question that I got recently when it came to the wiring on a motor. So this is the motor that's going to go back onto the featherweight back here. And I've reassembled it, and I'm going to talk to you about how I like to try to wire these motors when I can, as far as replacing some of this wiring here. But first, a viewer reached out to me, and when they had removed the motor from the machine, these two wires both connect to the power block, and usually they're longer. I have cut them. The viewer said that the little connector that goes on the end came off of her wire when she was removing it from the power block. And what could they do? Hypothetically, you could put a new connector on the end of that old wire, and it would just require a little bit of trimming. So the way that you would do that, first of all, this is stranded wire in here, and it's covered with a rubber and a cloth. So the first thing you will be doing is trimming back a little bit of that wire, about that much, in order to attach a new connector. You're not losing that much length when you do that, but I will say you do run the risk of the wire being too short to stretch far enough to reach the point on the power block that it needs to attach to. But I'll show you what to do if you just wanted to replace the end that came off. So this is just to give you an example. I'm not doing that with this motor exactly. So I have a little clipper here, and instead of cutting it on the 18 mark, I actually cut it on the 14 or the 16 because I don't want to clip through any of the stranded wire. So I'd rather kind of get the cut started, and then I come in with a razor blade and finish off the job. So the first thing I would do, if I were just replacing the connector, and again, you would have more wire here if you were doing this. First, I would trim back just a little over 1/4 of an inch of the covering. And I'm going to start on the 14. I'm going to make a little kind of snip about right here. Once, I might rotate it and do it again, and it comes off. Then I'm going to clean up this wire. Make sure there isn't any of the threaded coating on this wire, and prepare it to attach my new connector. Now, dirty wire is never going to be a good conductor, so I like to, with just like a little bit of rubbing alcohol, kind of clean some of that dirt off the wires. And you could also even use a wire brush. I just find this makes a big difference when working with this old wiring. Whether you're getting ready to solder new wire on or you're just adding a new connector, make sure it's as clean as it possibly can be. So once I feel like I've cleaned it up enough, then I'm going to twist that little new portion up like that, and then I'm going to cut a piece of heat shrink tubing. This is about 1/2 inch or so, and I'm going to slide it over the existing wire and out of the way. If you forget to do this step and you connect this connector, you're going to have to take it off because there's no way to get the right size heat shrink over this connector. So once I have the heat shrink tubing over on the old wire, I'm going to take my little connector. And if I remember, I'll link these down. I get them on McMaster-Carr, but this little connector has a little cut in the tube here. You can see it's a circle with a cut right here. I'm going to take my crimpers and I'm going to make sure that the cut is pointing away from this little thumb that sticks out on my connector. Just going to grab it with my crimper, I'm going to slide the connector up onto the wire, and I'm going to give it a very good squeeze. I like to give it a double squeeze, and then release and give it a tug and make sure it's not coming off. Then I'm going to slide my heat shrink tubing up and then shrink it down. And I should be good to go now. This can be connected back onto the power block. That is what you would do if the connector broke on the end of the wire for the motor and you felt like you still had enough wire where you could make a little snip to expose some fresh copper and reattach a new connector. That's not what I'm doing with this one, obviously. So now let's get into how I like to rewire the motor, the light switch, and the light itself, which this is out of the light. We're going to deal with these and add new wires. So here's the field core before I put it all together. And what I want to talk about are these wires right here. Now, this wiring, I've inspected it. It's still good. It's not brittle. It's not melted, anything like that. These wires, one comes off each side of the field core. They are actually attached to the field core underneath this tape right here. The reason why I don't always cut them here, and I would undo this knot and cut the other side and start the new wiring here, is because I like to leave some of this original wiring in place in case something ever needs to be done again to the motor. It's nice to have the newer, thinner wire that I will be using when I'm feeding these wires through the grommet on the motor housing, because the new wires are so small, they fit easier through the grommet. But if you start pulling and tugging on these, which sometimes you need to do so that they're not pinched in a weird way and the motor won't spin, the way that they're attached in here is there's just one little wire that's coming to meet this bigger stranded wire here. I have before, after I clipped the wire here and soldered my new wire on, pulled on this, and it actually detached inside where it's connected. And for me, that was it. I couldn't fix that. I needed a new field core. So if I know the motor works and I know this wire isn't disintegrating, I will make my cut further down, leaving this wire here still intact with this little strain relief knot to kind of protect it from tugging and pulling. That is just how I like to do it. I cannot always do that with a motor, but when I can, I do. And you will see where I choose to cut the wire. But I just wanted you to see all of this and understand we can cut it here and attach the new wire right up against the field core. But once that's done, that's it. You can't ever do it again. I hope I explained that well. Let's get back to the rest of the video. So starting with the motor, this is just my theory. I showed you the inside of this motor, the field core. We know these wires come up inside the motor. There's a strain relief knot tied, and then they're connected, each wire to one side of the field core. Actually, it would be up here where they're connected. Sometimes these wires I have to reconnect up against the field core itself. But if I feel like the wiring is in good condition, I like to make my connection down here. That is my choice. I like to leave some of this wire in place in case work ever needs to be done again to the wiring. So what do I do? Well, the motor sits on the machine like this. The wires come out through the motor housing, and then they kind of have a little bend in them right here, and they go through the body of the machine. So let me show you. The wires are going to come down out of the bottom of the motor, and then they're going to bend up into this opening right here. So my theory is where these wires bend, right here where they come up and they're straight for a little bit, there's not a lot of bend in the wire there, that's where I like to cut my wire and make my new connections. So I'm going to cut both of these wires about right here, and that's where my new connection is going to be. Now I need to strip both of these wires, and I'm going to strip them back just a little bit more than 1/2 of an inch. Next, I need to clean these off. There's still actually thread wrapped around these wires. I only got the outer part of the coating off so far. So once I've got all the little thread that was wrapped around there peeled off, I'm going to clean these off. And the reason why is the solder that I'm going to use is not going to flow very well onto dirty copper wire. The cleaner, the better. This makes a difference. Trust me. Once I feel like these are clean and there's not a bunch of gunk on them, before I twist these and get ready to solder on my new connection, I am going to actually put just a little bit of flux on them. This is to help that solder flow. It's not going to have an issue flowing on the new wire at all. On the older wire, I feel like I have more of an issue. So I like to work that flux in there a little bit, and then I twist these up, and I'm ready for my new wire. I use Singer brand wire. This is copper 18 gauge stranded wire. I have tried others. Bob Fowler is the one who turned me on to this product, and I will never look back. Now I have a red and a black wire of decent length. I know I have them more than long enough to feed up through the body of the motor and connect to the power block. So I'm going to start with the red, which it's hard to tell, but that's this one here. And I'm going to strip it back just a little more than an inch. There we go. And I'm also going to twist this wire. Now, starting with my red, and by the way, I'm working on, it's like a Teflon cloth. It's used sometimes when people iron on the iron-ons for t-shirts or whatever. I like to work on this when I'm soldering. If I get a drop of solder somewhere, it just flicks right off. So that's what I like to use. But I'm going to wrap this wire now around my old wire. And I like to leave just a little tail that I can clip off later. Just like that. It's got a good 2 to 3 wraps. Now I'm ready to solder it, making sure my solder tip is clean. And I need to heat up this wire, and I'm going to let that wire get hot and just let it flow onto my joint. Now usually I run a fan. I'll show it to you in a second. Okay, that's traveled well. And let's check this. I want to make sure that it flowed all the way around, and it did. And then with my little flush cutters, I'm going to trim off this little extra tail here, just like that. Now, I can go ahead and put my heat shrink tubing onto this wire. And you just have to have one that's big enough to fit over the old wire. Okay, and let's shrink it down. There we go. So just lather, rinse, repeat, as they say on the other side. And then I'll add one more layer of heat shrink tubing here before I put the motor on. But for now, that's done. All I have to do is put my little connectors on the ends, and I don't do that until after the motor is on the machine, so I know exactly how long to cut this wire. So let's look at doing the light switch next. So this was a task for me to figure out the best way to work with the light switch. And I'm going to show you a little trick I saw. I think I saw it somewhere on YouTube. I don't even remember now. This is Loctite. This is the pack it came in, Fun Tack they call it. I'm going to use this to help me hold this down while I'm working on it. But first I want to clean this up a little bit. So I'm going to use a wire brush on the switch. And I'm just cleaning all the gunk out of the threads here, so when I put that little washer and plastic thumb nut back on, it glides on really easily. Now, what I want to do is replace this wire, and it's soldered on right here. I'm going to clean this off first before I even try to remove the old solder. Now I've cleaned that off, but I'm also just going to give it a little bit of a rub, a scratch here to kind of rub away any extra gunk that the alcohol didn't get. I just find if I get this a little scratched, see how it's a little bit shiny right there now? This old solder melts so much easier and faster if I do that first. I use a solder sucker to suck off that hot solder. And I'm just going to take the switch so it holds still for me. I'm going to press it up into the Loctite. And now see, it's not going anywhere. I'm going to hold my soldering iron onto the solder and just wait. And this may take a little bit, but you will see it start to melt. Another thing you can do is kind of wiggle the end of this old wire here. That usually will let you know when things are starting to melt. And I always do this with my fan, which I am going to show you that fan. There, it's starting to melt a little bit. See if I could wiggle this wire out. There we go. Now, solder sucker. This has a tip on it, and it just sucks that solder up. And I normally have to do that once or twice. But watch this. It just ejected all that old solder and it's ready for me to use again. This is like a silicone tip, so it doesn't really melt. But once I get this wire off, what I want to do is I want to check right here is a hole. It should have a hole. It's not there yet because there's a bunch of old solder in there. So I want to make sure I get the solder out of that hole before I put my new wire in. I'm just melting that solder down so hopefully I can suck it up. We'll see if I got it all. Yes. So look, you can now see the opening. That's where the new wire needs to go through. So I'm going to clean this up a little bit and then we're going to put the new wire on. So I'm going to use red for the switch and I just need to trim a tiny little bit off here. And I'm going to twist this. Then I'm going to feed it through the hole. Make sure all the wires go up into the hole. Now we're ready to add new solder. Letting that heat up. You don't need a big glob of this. Let's see how that looks. There we go. It is connected. Giving it a tug, it's fine. And this will also get a connector after it's on the machine. So I make sure that I don't cut this too short. These are the last two things that need new wires. Now, when I cut these off of the light, because I'm getting rid of that lead sheath totally, I leave as much as I can here. It just gives me something to work with. I like to use my little alligator clip. And I've already cleaned these off. I've polished them up, and I've also cleaned off this solder here and kind of brushed it with a wire brush to get any gunk off. So hopefully that solder is going to melt for me a little bit easier. I have the solder sucker ready. And I'm just going to hold this up and wait for it to melt. And sometimes this takes longer than you think, so you just have to be patient. Okay, it's starting to melt. I'm just going to give it a little flick here in a second and it should just pop right off. There we go. Let's see how that did. So this is very hot. I don't want to touch it. I'm just going to use my sweater to, this will even get hot. And I'm going to do the other one too. In the alligator clip, I'm always making sure that the tip of my soldering iron is clean. That makes another big difference. I re-tin my tips with a tip tinner. I'll try to link all this on Amazon if that's where I got it. My soldering iron came from Harbor Freight, I believe. There it goes. Okay. Do you see how the solder is coming down the side here? You don't want a lot coming down the sides or these pins won't fit back in the hole like they're supposed to. So I'm mostly just making sure that it's clean enough. If it's a little bit right here, that's not going to hurt anything. But if it's further down on the pin, it will. So I think I can put a new wire on this and it will be fine. So I'm just going to let it go, let it cool. and we're going to put the first wire on. This one's still warm, believe it or not. The wire is going to lay, so the stripped wire is going to lay right here, and it's going to come off this way. So I like to clip it in my little alligator clip like that. And I cut longer than I need. Always better to have more than you need instead of not enough. And I'm going to strip about the same amount back that I did for the light switch. Don't need a bunch of it showing. Just about, that's a little over 1/4 of an inch. And of course, give it a twist. It just holds all those little tiny strands in place for you. You just kind of want to center it on like that. And by the way, the solder is it's a hollow core. It's flux filled inside, which helps this solder flow so much better. There we go. So that is hot, but it's attached, and what I want to make sure is that I didn't get solder anywhere where it shouldn't be. So I'm going to grab the rest of the light and make sure this fits down in the hole. So I have the plastic body, and yes, it fits fine. So one done, and then I just do the same for the other one, and it's exactly the same. So I'll do that. Now I want to talk about this because when we are working with solder, especially if you're going to use a solder that has lead in it, they do have lead free, but what you're taking off isn't lead free, trust me. This is a little fan on Amazon. You turn it on and it actually, I'm going to turn it off, but it sucks the smoke away from your face and through a filter. You hear that? Through a filter, that it just makes it safer for you. You don't want to breathe that. And I believe this came with one replacement filter. I think this was around $25. I feel better knowing that when I'm soldering, I run this and I'm not inhaling all those chemicals. So let me move this out of the way. So as you know, when you take a light out of a featherweight, it's actually stiff because it's covered with lead tubing. I like to get rid of that totally. So my solution for fixing that is I'm going to be using this piece of wire here. This is solid copper wire. It is very stiff. I cut a length. For me, the magic number is 7¼ inches. That's what I like to cut to make this work. I am going to pop my little connectors into the plastic part of this light housing here. Make sure that they're flush, and then I'm going to put the back on. Okay, so that part is together. Now I'm going to take the little felt that goes inside the light. I'm going to drop it in, line up the hole in the felt with the hole in the light housing, and drop this piece in. The screw here goes in the back. Before I put this little screw that's going to kind of lock down these wires and keep them from bending all over the place, I'm going to do the rest of my setup here for this wiring. So I'm taking my copper wire and I'm going to cut a piece of heat shrink tubing that is just slightly longer than the copper wire. That's barely 1/4 of an inch. First, I'm going to give this a little bend so it slides on. I'm going to slide the wiring from the light in first into the heat shrink tubing all the way up into the housing like that, up against the light. Then I'm going to slide that stiff wire up in with it. And I want to get it all the way up so that this little end here is not sticking out at all. So just give it a little shove. There, it's totally up inside. It's not sticking out the end. Now I'm going to hit this with the heat gun. And when it's all shrunk down, I'm going to add my last screw. And don't You want this tightened down so the wire doesn't move, but you don't want to tighten it down so far that you damage the wire. So just make sure it's snug and there's not a lot of bend here. And this is ready to go back on the machine. These will be trimmed after I have the light in the machine and I've measured how much room I need, how much length to properly reach the power block pins that each one of these wires go on. So what did we do? We rewired the light, got rid of the lead sheath, and I showed you how to add new wiring with heat shrink tubing and some solid strand copper wire to make it nice and stiff. That is so these wires don't hit up against the metal gears in the machine, which would obviously be bad. I talked to you about how I like to rewire a motor. There are definitely more than one way to do it. I like to preserve some wire coming out of the field core if I can, and I explained why. Let me know what you think about that. We rewired the light switch. And if you want to see how all this goes back in the machine, I will link the video below. I think before we leave, I will show you this machine back together and running so you know that it works and that I didn't mess it up. And just remember, this is how I do it. Electrical is no joke. You do not want to be electrocuted. You do not want to start a fire. If you are not comfortable doing this, have someone else do it for you. By all means, that is okay. I have held off on making this video for a long time because I don't ever want anyone to have a nasty accident in their house because of something I said for them to try. So keep that in mind. This is how I do it. If you don't want to, have someone else do it. All right, let's check her out, all back together and running. And here she is. She's not done yet, but she does work. We have the light, you can see off and on. And I have engaged the stop motion feature, and I'm going to press the foot control. She works great. Back off. She's going to be a beauty. Thank you all so much for watching. I have to say one more time, this is how I do it. If you're not comfortable wiring a machine, you should not try. Let the experts do it for you. I have learned a lot from a lot of good teachers along the way on my featherweight journey, and I'm comfortable doing this now. And you can see the end results are great. Let me know if you have questions in the comment section below, and don't forget to give this video a thumbs up before you leave. Thank you so much for watching. I'm going to get back to work. I'll see you guys again really soon. Bye.